Hello all, I am Ritul, team leader of Team TechQ from Rajalakshmi Institute of Technology. Our problem statement is to make an automatic regulation of valves for release of water based upon soil moisture availability in the root zone of the crop using artificial intelligence in a piped and micro irrigation system. So, here is our idea for the given problem statement. So, our solution firstly start with the utilization of the AI in the automatic regulation of valve for the micro irrigation system. So, basically, the AI algorithm adapts to the changing condition for optimizing water release based on the real time data. It basically enables the data driven decision making for irrigation, improving the agricultural outcomes. It provides flexibility in adjusting water release as per the data that is given by the user. It also supports remote control and monitoring, allowing the farmer to manage the irrigation from anywhere. It basically minimizes the water wastage by only giving the precise level to the crop that is needed at that moment. Secondly, we have used the machine learning model to get efficient micro irrigation output. So basically we have used the machine learning model or machine learning algorithms for data analysis and pattern recognition. It utilizes the data that we have got from the user to analyze it and to get a pattern to give the precise water level for the irrigation. It also adapts the irrigation patterns based on the seasonal changes and crop specific requirement. It also basically supports predictive maintenance by analyzing equipment performance data. It provides personalized recommendation from the farmer for better crop management. It facilitates precision agricultural practices, ensuring that the optimal water usage for plant has been reached correctly. The next thing that we have considered the inputs like temperature, humidity, growth stage and also the soil type. We have considered these factors because these factors also affect the plant in some or the other way to get more water or to reduce the water. Since humidity level affect the rate of moisture loss from soil and plants, impacting irrigation need. And also growth stage information helps the farmer to irrigate the crop as per its requirement in different growth stages. The soil type mainly determines the water retention and the drainage properties, influencing irrigation frequency and duration. And thus we have considered these factors mainly also to give the precise level of water to the crop as per its need at that moment by sensing the data that we have got from the sensors we have used. Next, we have created an application software that is developed for monitoring the moisture level, temperature and humidity. This software is also used to get the input from the user such as the growth stage, the soil type and the crop name. It also displays the real-time soil moisture levels and temperature and humidity data graphically. It also enables the farmer to know whether the plant has received the required water at the moment. And also this app alarms the farmer when the water level is raised or it is under the below required water range. It also an user-friendly interface accessible in any kind of devices like smartphones, tab or computer. So This app is used to send the moisture level notification to the user. It sends instant notification to the farmer's device when soil moisture level deviate from the range that is needed for the crop. It differentiates between the mild, moderate, and severe deviation, allowing the farmer to make the prioritized actions. It also provides actionable recommendations alongside notification to guide farmers on irrigation adjustment. And the next is the capacitive soil moisture sensor, which we have used is used for high corrosive resistance. It can withstand higher corrosive resistance value, and that is why we have used this sensor to get the present soil moisture sensor, which is also shown in the app we have created. So to implement these ideas, we have used these technologies to make our hardware and successful one. So we have used Python for the machine learning model and for programming purposes. Next we have used DHT22 sensor, which collects the temperature and humidity, which is also fed into the machine learning model to make the precise decision. DHT222 sensor gives the precise temperature and humidity measurement, and it is very accurate, and that is why we have used this DHT222 sensor. It also consumes minimal power and also suitable for prolonged use without frequent battery changes.
It's
Next,
a
we have used
microcontroller
Node
board.
MCU for primary processing unit and it for its inbuilt Wi-Fi facility for the application we have taken. It is programmable using Arduino IDE and Lua scripting language for our hardware purpose. Then we have used the ToSmart for the user interface that I have already mentioned before. Also, we have used the capacitive soil masser as also mentioned before.
And now we are here to see the working of our model. Here I have powered the board with the charger. Now let's see. Now we have kept the capacitive soil moisture sensor in this plant. This plant is already watered, so now it has a required soil moisture, hence the relay is glowing and the motor is not turned on. You can see no water is coming out of the pipe. So now we are going to see the working of our model. I have already powered my board. This is the Node MCU. I have kept our submersible motor under water. So now we are going to check with this plant. I have already kept the moisture inside it. I just watered the plant, so now it has required moisture. You can see the relay, it glows, which means the soil has enough moisture for the plant. Now if I take the soil moisture, you can see the motor is working and it is giving out the water. So now we can irrigate the crop. This is how our model works.